All right. So today we're going to be covering some two-axis functions from inside of Bobcad that go along with one of our most recent blog posts. The first thing we're going to take a look at is open pocketing and how we can do it and make it a little bit easier than it used to be, because in the old versions you had to extract edges. I'm going to show you how to do that, but we're also going to do it a different way. So to get started, I just have to come over here. I'm going to right click on CAM defaults and start a new job. And then I'm going to go ahead and use my BC3X mill, just my generic machine here. And then I'm going to run my stock wizard. So stock wizard, the workpiece is my solid model that represents the final part. And I made a very simple part for this, but I'm just going to pick that. And then make sure you hit next. Don't hit OK. If you hit OK, it closes this whole thing and we don't get a chance to do the stock. We'll have to go back into it in a minute. So I'm just going to hit the forward arrow, the one that says stock wizard when you hover over it. And right here, it's going to create a piece of stock. Now, in this case, I'm going to use just a rectangular piece of stock. It's 4 inches by 3 inches by 1.5 inches tall. I have enough room that my vise can hold on to the bottom of the part, though I don't have one in here. I know I can hold on to about 1/2 inch of this. That's how tall this ledge is. So I have at least that much. I'd probably be trying to hold on to less than that. I'd be holding on to 200 or 300 thousandths of this, just so my tool has the clearance over the jaws of the vise to actually make the cuts. But I'm not going to change anything here. Just going to hit the forward key. So once again, we then have to set our origin. So you could set right here, I'm at top dead center. I can go and say I want to use my solid jaw and pick that one. Whatever you want to use for your origin. This is the work offset, the G54, the E1, whatever your machine calls that work offset. Some machines don't even have work offsets. I've been working with a lot of routers lately and plasmas that don't use a work offset. They actually use a G92. So basically, that is wherever the head of the machine is sitting when I hit go, that's where we're going to go from. So we're going to base everything off of that location where we start. In my case, I do have a full simulation so I can see my machine. And it can cause problems sometimes because when I'm defining my 0 location, we're defining the same, or we're putting the part in the 0 location of the virtual machine inside the simulation. So what ends up happening is if I pick the top of my part, the rest of my part, the rest of this thickness here, ends up inside the table of my virtual machine, and I end up getting a whole bunch of errors throughout the program. So all I'm going to do is scroll down into here where it has our work offset. I'm going to use work offset 1, G54, E1, whatever your machine calls it. And I'm just going to take my Z and lift it up 2 inches. Now, if you don't have Machine Simulation Pro on your license, you won't have to do that. It's just for this situation where I do have the machine. And then right down here, I have my clearance plane set to 1 inch, and I'm fine with that one. So we can hit OK. And then that creates the job. We now have our stock, and right now we're ready to go start machining this thing. Before I go machine it, I want to show you guys, if you're not sure if you have Machine Simulation Pro on your license, you can go up here to File, and then down to Help, and then right here to Show License Status. And just wait, and it's going to pull up a box right here that shows you all of the items on your license. And what you're looking for is the Simulation Pro right here. If you don't have Simulation Pro, then you're not going to be able to see the machine anyway. So doing that adjustment and making that shift that I just made to lift my part up doesn't actually affect anything. So I'm going to go ahead and blank out the stock. Thank you. I'm going to go ahead and blank out this stock so we can get rid of all of that, just so I don't have to look at it anymore. And now we could start machining this. Now, in the past, the way you would do open pocketing was with wireframe geometry. And so the normal steps would be you'd right click, add a new layer, call it open pocket, and then extract your edges. So you'd go to create 2D, extract edges, and I'm just going to go ahead and pick this floor here and this floor here. Now, when I hit those two, I can hit OK and cancel out. Now, if I turn off the layer that has the solid model, which is my CAD layer right now, I'm left with two pieces of wireframe. So what I would then need to do is go in and pick all the lines where the tool is allowed to leave the part. So in this case, it can leave the part through this gap here, and it can also leave the part through or over this edge here. And what we would do with that would be right click, modify attributes, line style, and then we would change those lines to a dotted line. And that tells the system that we are allowed to leave over those edges. Every other solid line that we have would be treated as a wall. The other thing to take note of is wherever this dotted line is, a finish pass does not get applied to that section. So I'm not going to do a finish pass on that slot right there or this whole edge right there. So we have our part. Give me 1 second. I'm just going to turn this to do not disturb. Right there. So let me just close that down so I don't get any more interruptions. There we go. So that would be one way to do your open pocketing. It's not the way we're going to do it today because we have a solid model. So when we have a solid model, this allows us to go in and do open pocketing automatically. So I'm going to go in to machine setup 1. I'm going to right click and I'm going to use a mill 2 axis. Now, technically, before I do this, I should set up the tools I plan on using. And I'm not going to use a lot of tools, so I could set them up on the fly. But I'm going to right click right here on milling tools and go into the tool crib. Now, inside the tool crib, we can then go in and pick the tools we plan on using. In my case, I'm just going to go down to the mill section and then right here to end mill rough. And I'm going to go ahead and sort by my diameter and then scroll down. For this one, I'm going to go ahead and use a 3/8 end mill. Now, what I want to take note of is specifically the flute length of the end mill right here. So we have a long version, we have a standard version or a shorter one, and we have to think about what's the deepest cut we need to make. Well, the wall that we have on the part right here, that's 1 inch tall. And this pocket's 3/4 of an inch. So if I was to go and choose this shorter standard one, it's not going to be long enough to cut the full 1 inch. So I'm going to go ahead and choose the long one. Now to add that to my tool crib, down here's the library, here's the crib. I can grab it and drag it right into there and drop it in. And now I have that 3/8 flat end mill. If I need to modify that tool, I can double click on it and it's going to bring up the edit tool parameters. So I could go in and change anything about it, like the tool material, the protrusion, number of flutes, whatever you need to change, you can change it. And this would be a good time to do it. We could also change it later on inside the feature. So I'm just going to hit OK. And I'm going to say, I'm going to use that 3/8 flat end mill for all of this. And I'll just go ahead and hit OK. And now we can right click on our machine setup 1 and do a mill 2 axis. From here, we're going to select our geometry. So I'm going to start by cutting this floor. Now remember, with 2 axis in general, anytime a piece of geometry is at a different level, we have to make those separate tool paths. So in this case, I can't do both of these at the same time because this is higher than this one and all my depths and everything that we set up are going to be based off of this. But I want to machine this side first. I want to machine this section first so that we can then go in and machine this one freely. So I'm going to pick that floor right there. And then I can drop straight down and there's a button that says detect open edges. When we turn that on, it is now recognizing that there is open edges around 3 of the 4 sides of that shape. I could then go into the profile chains and just make sure that the start point is going the correct direction. This is the entire direction. If we're compensated to the left for a climb mill, that'll be perfect. I can use that for my finish pass. The other thing is we need to set the depth. And so I need to pick the bottom. I'll go ahead and pick any edge that represents the bottom. Doesn't matter where, as long as it's the same. And you'll see we're going 1 inch deep. So now I can hit OK and then hit next. Now on the feature page, we have our clearance plane, our rapid plane, and our feed plane. Remember, your clearance plane is the safe area above anything on the job. So you're going to make sure that's the highest. You have your rapid plane, which if we were doing 2 pockets, we'd use the rapid plane to get from one pocket to the other. And then the feed plane is where we're always going to feed in from. So if you ever have 2 pockets and you have to clear over the top of, say a bolt, so you raise your rapid plane to 0.5, instead of feeding from a ½ inch above the top of part, we're going to rapid down to 100 thousandths above the top of part and then start feeding in. My top of feature is set to 0 because my origin is at the top of the material. And then my total depth is going 1 inch deep. And take note, you do not have to use a negative value inside your total depth. From here, we're just going to hit next. We have our machining strategy tab. Now, the feature we're specifically looking at is the open pocketing feature. So we need to be using a pocketing routine to do it. So we'll have a pocket, and then we'll also have a profile finish. And again, the profile finish is only going to go and put a finish pass on the edges that show as walls. From here, we can hit next. Right here, we have our tabs. Now, tabs are not something I'm going to use on a pocket, but you might use them on a profile rough or a profile finish. Next, again, we get to our posting tab, where we have work offset number 1, which should match the work offset that we put inside the machine setup. And then we also have our contour ramping output. This output rotary angle isn't something we use primarily. So contour ramping is a profile roughing toolpath where as we profile around the outside of the part, we're also dropping down in Z. If it's a round part, it looks just like a spiral. But if it's a rectangle, it will also go around. In this case, all it's asking for is if we were to use that feature, what kind of arc moves or line moves do we have to output? Do we have to output lines because our machine can't handle arcs, or can we output arcs? Doesn't really apply to this toolpath, but we'll go ahead and hit next. Right here, because we set up a tool inside the tool crib, we are able to grab that tool and bring it in automatically. We don't have to change anything. But what if we got to this point and we realized, I made my tool high-speed steel when it should have been, something else. Should have been high-speed steel or a carbide or insert. Well, you can't change that one. And so if you uncheck system tool, the only thing you can really do is modify the tool from up here. So if we click on this drop down, I can go in and say, I want to modify this tool. And then right here, I could make my changes. So it allows me to, maybe I pick a tool that's a little too short for what I'm trying to do. I could extend the length of the tool here. I could also go in and change, say, the material. When we change the material and I hit OK, you're going to see this value right here. The surface footage per minute is going to change. And so I'm just going to hit OK. And there's the surface footage when we're using carbide. Now, I believe I have like a 1018 carbon steel set. So it may not be exactly what we want. I didn't even set the material because I didn't think of it. I could change it afterwards. Or it all really boils down to how you are going to put in your feeds and speeds. If you're just going to manually enter in what your spindle RPM is and your cutting feed rate and your plunge feed rate, if you're just typing that stuff in, the material of the tool and even the material for the job doesn't matter. The feeds and speeds you're entering in are the feeds and speeds for the job. If we do ever want to change that, we just uncheck the feeds and speeds. We enter our spindle RPM, our cutting feed rate, and our plunge feed rate. After we have that page set up, we're just going to hit next. Right here for the the patterns, we have 2 different pocketing types. You have a standard pocket and you have an advanced pocket. Standard pockets are never allowed to do open pocketing, even if the geometry tells it to do an open pocket. So I'm going to leave it on a standard offset pocket out now for right now, and then we're going to come back and change this so that it does come out correct. But this only works, again, if the button that you checked earlier for detect open edges is on and you're using an advanced pocket. Now, the reason my values might be a little different than yours is because at some point, I believe in the last week or so, while I was going through this feature, I hit this Save Defaults button. Now, when I hit Save Defaults, it allows me to save the information for my pocket and my profile finish. And you can do this anytime you notice that there's settings that you consistently have to change and turn on, save it. That way you don't have to change them every time. Do what's going to be used most often. For me, a lot of times when I'm doing a traditional style toolpath, 40% is going to be my step over. So I set it up so that that becomes my default. But depending on your tools, depending on your materials, you may go a little lighter or a little heavier. Go a little faster or go a little slower. I'm going to go with the offset pocket out. That's a traditional style pocket. We're going to start on the inside and we're going to work our way out. And again, we'll come back and fix this because it's not going to work right now. Next, again, we have our parameters. Now, inside of parameters, we have our allowances, how much we're leaving on the part for another tool to come in and finish. The side allowance default is 15 thousandths, and I could go ahead and say I want to do it at, 15 thousandths is fine. That's all the finish pass is going to have to clean up. Bottom allowance I primarily don't use. If I don't want to cut all the way to the bottom, I'm just going to define the depth of the job to cut not all the way to the bottom. So instead of going 1 inch deep, I would go 0.9, and I'd leave 100 thousandths that I could then use either a different tool on or different feeds and speeds so I can ensure that I get a good, clean finish. Now, the depth, you can either do a single step, so it's going to do the full thing in one shot, or you could do multiple steps. And in multiple steps, I can go in and say, I want to break this down into 0.15, so 150 thousandths per pass. And we're going to do 7 passes all the way down. Next, we then have our leads. How do we get into the material? Well, the nice thing about an open pocket is it recognizes where the open pocket is, and it will work from that open pocket. And usually you'll get your plunge moves outside the part. So I'm going to leave it on plunge for now. And if we need to change it, we could always come back and make that change. Next, again, we run into our machine sequencing, and usually it's set to closest here. But again, I've been saving defaults to show some guys. And so I usually use Optimize. Optimize allows us to let the system choose the sorting order. And what it does is it picks out of these top 4 options between closest, no sorting, X and Y direction. It'll pick the most, the best option for that. The thing is, we're only cutting one part. We're only cutting the one floor right now. So it really doesn't matter what you pick. We're going to cut the one floor no matter what. Next, again, we run into our linking moves. Now, the linking moves, because we're using a standard toolpath, all we have is direct links. So when we make a cut, we're going to go directly to the next cut. Make the full cut, go directly to the next one. That's all we get. So I'm going to leave them there. Next, again, we have our advanced feed rates. The first one is convert rapids to feeds. This allows us to convert any rapid G00 moves in the G code to G01 feed moves, and then you would actually define a feed rate to use them. And that's to help with an issue called dogleg rapiding that happens on some machines. Not all machines, but it happens on some machines. And if you ever see a rapid move that's not moving in a straight line, it's more like a check mark shape, then that's a sign that you have dogleg rapids. Even that doesn't mean you have to use this all the time. The only time I even worry about dogleg rapids are if I have some sort of fixture that's sitting on top of my part, that if I was to go in and do my rapid, where normally I would, in Bobcat, it'll show it rapiding in a straight line, but at the machine, it might kind of do that check mark shape. The only time I'm going to use this is if I'm concerned with myself hitting anything that's sticking up above my part. I'm not going to use it now. The next one is our corner slowdown. This allows us to slow down as we approach a corner to a specific percentage of our cutting feed rate, a certain distance from the corner, and then it'll recognize corners as anything with 5 degrees to 175 degrees worth of angle or any difference there. But I'm not going to use that and then hit next. Right here we have our MDI. MDI is an awesome feature for people that need to use it or want to use it, but for most of us, it's not something we're going to use very often. What I've been using it for lately is when I finish this pocket toolpath, maybe I want to go in and see what it looks like before the next tool comes in. Now, depending on how your post is set up, a lot of you guys will have an MO1, a optional stop at the end of each toolpath. And that's there for you to turn on your optional stop at the machine and have it actually stop when you get to that point. But if you don't want to run optional stop, because then you have to hit, go a bunch more times, then what you can also do is say before the tool change, after the tool change, or after the operation. So you could choose. So before the tool change happens before we actually cut this pocketing feature. So you could do something there. After the tool change, it's going to change the tool, but then it's going to output another line of code if we wanted to. The last one is the one I'm going to use, which is called after operation. And if I expand this out, you'll just see a line. I'm going to go ahead and rename this line stop. From here, I like to use this raw text feature. So I can take that, click on it, and then add it as a command right here. So you hit that little gear with the green plus sign, and it's going to add that raw text into the feature. Now what I could do is either leave this as raw text, or I could do it as a comment. So I'm going to say raw text, and I want to put an M00, and then I'm going to add one more chunk of raw text, and then add a comment. So this M00 is going to open up, the machine's going to read it. But if I choose the comment option, this is where I can put a note for myself. Stopping machine to check rough cut. And now the machine's going to stop when it gets there. You're also going to have a note inside that line of code that says we're stopping the machine to check the rough cut. And if you needed to add more, you could. I'm going to go ahead right here and hit compute. Actually, no, we're not. We still have the finish pass. So we're going to hit next. Right here, we have our finish pass. So I want to use the same tool for both the rough and the finish, but be aware that the finish tool is actually pulling from a different category. And this causes problems a lot of times when guys are using half-inch flat end mills, because that is our default tool. It's one of the first tools we're going to put in here. That's why this one's here now. When we do this, we want to make sure that we have either the same tool or just the right size. Now, if you were to use a different tool, say I wanted to use a rougher for my 3/8 on the start, and then on this second one, I want to use more of a finisher. Well, I could go in and define that I want to use another 3/8 tool, but you'll notice that it's going to be tool number 2. Well, that's because our first one was tool number 1. The second one is tool number 2, but it's getting pulled not from the end mill rough category, but the end mill finish category. So you end up with 2 different kind of sections where the tools came from. In our case, though, we do want to use the same tool. So I'm going to uncheck system tool. I'm going to click this drop down, and I'm going to pick tool 1 or my 3/8 flat end mill long. Excuse me. Once again, we would go and factor in feeds and speeds, plug those in. Next, again, we have our patterns. On the patterns page for a finish pass, we only have one tool path. It's a standard cut. It's just going to go around the whole diameter or length. It's going to go the full part. All right. We then have the choice of our compensation. So system compensation means we're going to offset the tool, in our case for the climb mill, to the left, so that if our tool was the right size and it's exactly 3/8, it's going to cut based off the radius. It's going to actually offset the tool path over by the radius of the tool you're using. So the center of the tool is going to run down. The problem is tools wear out, things happen. So I want the ability to adjust what I'm cutting. One of the ways to do that is to use your machine compensation. Now, if you don't have machine compensation or you don't know how to use it, one way of getting this done would be to actually go back to the page prior where we're setting up the tool and set it to the tool diameter, the real tool diameter. Maybe it's not 0.375 anymore. It's a little bit smaller. I'm not going to worry about that right now. All I'm going to say is if I want machine compensation, I can turn them on. Now, in this case, I am compensating already using system compensation to offset over half the diameter of the tool, the radius of the tool. So in this case, it'll be 3/16 from the lines that I chose. My G41 will then show up inside the G code, and it gives me the ability to edit it. Now, you do have to be careful. Some machines will let you set a G41 based off the wear offset in the machine. Others, you may define your full diameter And in that case, you might actually run with your system compensation turned off, which in Bobcad will look like a center line cut. But when we post the code, you will have that G41 so you can still compensate. I'm going to go ahead and run both of them. And then down here, we have spring passes. Spring passes are a fantastic little function to allow us to get a few extra passes on a part. If the wall is very critical, then spring passes are a good way to kind of make your initial rough cut and then go in and cut it a few more times so we can get rid of that bit of deflection we have at the bottom of the pocket because the tools got deflected. So I'm going to say, let's do spring passes. Let's do 2 spring passes. So in our case, it should really only finish this wall, but for now, it's going to actually finish everything because we haven't set up the open pocketing yet. Next, again, we get to our parameters page. It's a finish pass. We're not leaving anything, so it's going to be all zeroed out. We're going to a total depth of 1 inch. This is, again, a finish pass, so most of the material should be gone. And I do want it to do one nice cleanup, especially with the spring passes, but do a really nice cleanup on the walls that when we roughed it, we cut it into steps because we went with 150,000. So you're going to see a mark on the walls every 150 thousandths until you run your finish pass. So I'm going to leave it right there and say next. For the leads, how do we get into the part? Well, really, this is going to depend on the geometry that you're trying to work with. In my case, I'm going to go with a parallel, and I'll just leave it right there at 1/4 inch. That's over half the diameter of my tool, which is my rule of thumb. Use the radius of your tool for your leads. But that's over what my half diameter is, so I'm good with it there. Next, again, we get our corner types, no changes. Next, again, we have our machine sequencing. Now, we saw this earlier in the pocketing. And again, mine is saved, so it's on optimized. Again, this really doesn't factor in if we're only doing 1 pocket. If we were doing 9 pockets like that picture shows, it's going to be how we sort those 9 pockets. Next, again, we have our advanced feeds. So again, we have our convert rapids to feeds and our corner slowdown, but we also have lead in and lead out feed rate percentages, increasing or decreasing your layout, your feed rate, specifically when leading in or leading out. Sometimes what I'll do is I'll turn on my lead out feed rate and I'll set this to 150 because it's going to add an extra amount. And by speeding up that lead out, I'm going to get off the wall a little bit quicker than if I was to sit there and, try and machine past it. So we're going to turn that off. No corner slowdowns or anything. And then once again, we have our MDI. So I'm just going to go over here and hit finish. Now, a lot of people ask me, why hit finish? What's the difference between finish and compute? Finish saves all these settings that we put in, but it does not compute the toolpath, where compute will create all of it. So if you're in your kind of testing phase for doing a job, I would recommend doing a finish because then we can see, what we have. The other thing is when we hit finish, nothing gets calculated. So now I have to go in and compute that toolpath. But before I go and do that, I'm just going to go up here and hit save, just so we can save the toolpath for maybe another time. Someone might use this one again. Now, there's our geometry, the floor, and then you'll see here is, so you'll see when we compute this, we'll actually have results. So if I right-click on this feature 2 axis, now that I've saved, I can hit compute all toolpath. And there it is. None of those pieces of geometry are clearing over the edge of the part at all, other than the finish pass. And it's only going to pass there because I told it to add leads. So to do open pocketing, we're just going to go right here and double click on the pocket inside the cam tree. We have the correct tool. So we'll go next. The big change that we need to make is going to be, instead of using a standard pocket, we're going to use an advanced pocket. And if we go with the offset pocket out, it's the same strategy as what we were using on the standard pocket. So I'm going to go offset pocket out. Should start on the inside of the part and work its way out from there. And then right down here, we have our cut direction. We're going to keep it on one way. Again, how much do we step over between each pass? And then next, we have our parameters. So just like the earlier toolpath I did, because I have a rough and a finish, we're still going to have our side allowance and everything. So there we have it. Next, we then have our leads, and everything else is pretty much going to stay the same. Now, when we're all done, we don't really have to mess with the finish pass. That was doing exactly what we wanted. But when we're all done, you don't have to get all the way to the end. We could just hit compute. And we're just going to wait. Now we'll see. Let me give this a save. Now we'll see it actually cut that 1 inch worth of material off. So just waiting for the simulation to load. Taking forever today. Oh, there it goes. Just popped up a second ago. There it is. All right, so now we can go in and we can slow it down a little bit, and we're just going to say run. I'll slow it down a bit more so we can see this first cut. So like I said, it's going to plunge in off of the part, if it can, and it's just going to cut. So there's one. There we go. So you'll see it's just cutting across there as a one-way machining strategy. Go ahead and fast forward this up a bit. There we go. So that is our part, just like that. So now what I can do is I can actually close out of this feature or close out of the simulation. And now we can take that same feature that we just made, the feature 2 axis with the pocket, we can copy it and we can paste it. So all I'm going to do before I do that is I'm going to right click on where it says feature 2 axis and say rename. And we're just going to call this open pocket 1. Now to do this other open pocket, we're going to right click on where we have open pocket 1. And you actually have 2 copying options now. There's copy and there's copy with geometry. Copy just copies the feature. It does not remember what geometry was in the feature, but copy with geometry will remember where it's in the feature. So however you want to use it. I'm going to go ahead and say copy on that open pocket 1 toolpath. Then I'm going to right click on machine setup 1 and say paste. Right here, we now have this option, geometry, default chain start point. But you'll see those are the same options we had up here. The difference is this one, we just brought in. We haven't picked any geometry yet, but it is asking, do you want to use the same top of feature? Yes, we're going to be at 0. And do you want to use the same depth steps or depth values? Not really, because I am going to change this, but it's not going to hurt anything. So whether I say yes or no here, the first thing we need to do when we copy and paste or we save and load a toolpath is we're going to right click on geometry, say reselect. And then all we're going to pick now is that floor right there, just like that. And then we can tell it that the distance down is not 1 inch, unless it is. I should be able to go in here. If your stock's anywhere compared to this, then you should be at, boom, 100. So, or the depth. So the depth we need on this one, we could go in and say, this guy right here. We have our face that we chose. We have our chain direction. And I'm actually good with it right there because I could do a really nice parallel lead in on that. So I'll hit OK. Now, if we look at our profile finish for the last one, we already had parallels. And since we copy and pasted, all I should have to do is right click on this feature and say compute all toolpath. And it's going to do it that way. Now, notice it didn't go through the edge right here. And the reason it didn't go through that edge is because when I went to go pick the geometry once again, and by the way, I double clicked on the word geometry there to open it back up, I just need to say detect open edges. Then hit OK, then recompute that part, and it's going to do those open edges for me. So if I blank everything out, we can see it a little bit better. We have our pocket here. We have our pocket down here. We have our finish pass doing just the wall there. And then we have our finish pass doing just this shape here. So now what I like to do is I'm going to put it in a good view. I'm going to hit save right here. So just save. And then we could go start our simulation. So I'll say start simulation. Just waiting on it to load. The heck is taking so long? There it goes. All right, so we can slow this down a little bit. There we go. And so then we'll say run. And you'll see it's just going to take it off one level at a time. We got one more pass. No, probably one after this too. There we go. That should be pretty close. That's what's left over. There we go. There we go. So we have our open pocketing set to detect open edges. Nice clean floors. There we go. So now when we're all done, we can close out of the simulation. And then if we like the way that all ran, we could be ready to go and post the G code now. But before we ever go and post the G code, the thing I always tell people to do is go down to the bottom tabs here where you have your data entry and your CAM tree. There should be one there called operations. Now, if you accidentally close a tab like operations, you can just go up to this top toolbar and right click, and then you can turn your operations back on. So there we have it. Inside this operation tree, we have the tree and then the tool tree. So this is all the tool paths that are using, that tool size. And you could have jobs where you have a bunch of different tools and it'll show what each one of them is doing or what part of the job they're working on. The other one is the operation tab. And the operation tab allows me to go in and basically assign, myself stuff. So this operation lets me tell it how I want this to run. But I do have to be careful since I have that open pocket here. If I was to do the pocket here and then the pocket here and then come back with the finish passes, well, I'm going to have a little bit more stock on this edge than I might be expecting. It shouldn't cause an issue. In this case, I think we'd be fine to do it. But I don't want to reorganize these. But if you do ever have to reorganize them, just grab them and drag them to where you want them to go. So you can grab it, drag it. Now we're doing the outside pocket there. We're doing the inside pocket, then the outside finish, and the inside finish. All right. We're going to keep it going with the exact order I have it going in the CAM tree. And to set that, you're just going to go up to this little button right up here, click, and then say individual tool. Sorry, not individual tool. That locks the tools together. We want to go with individual feature. Individual feature is going to keep the tool paths that we created going in the same organization as how we put the CAM tree together. You can still modify things afterwards. Like if I want to move a finish pass down to the bottom for when it's using the same, when it's doing another finish pass, I could. But in this case, a lot of this doesn't really even affect us because we're not using a different tool for the rough and the finish. We're using the same tool. So, all right. So we have our tool path right here. And now what we can do is post our code. So posting G code, the first thing you want to make sure of is that your machine is set correctly and that it has the correct post processor in it. I'm using this, again, generic BC3X mill, and it's going to work just fine. It's going to give me the code. Now, you would pick your specific machine to do that. And then when you do have the correct post processor right there, you can go right up here, and there's a big button that says Post under the Milling tab. And there is our toolpath. So it's going to go in. It's doing the first step of the open pocket. Keep going, keep going. This is a long one. right down here. Huh. There's our M00. I knew we had it in here right there. What is that on? That's on the finish pass. No, that's the rough pass. Okay, so we do have a pretty long rough pass is what I'm seeing here. That's where our M00 is going to output. Now, if you go to try and run something like this and you're unable to get that M00 or whatever command you wanted to output, a lot of times you'll get an error saying that it's missing the variable. Call tech support. We can help you with it. Should be fine. All right. So now, one last time before I fully save this, I'm going to shrink this up and let's go ahead and start our simulation again. And right here is where we can load it up. And we're just going to slow this down a little bit and then say run. And so we'll see it's just going to go in, start on the outside, and cut again. All right, so we're just verifying that this all looks good. It's running in the order we want it to run, and it's going to do exactly as we want. Run it quick. And there we have it. So there we have it. So we can close out of that. And then this would be time to post, save the code, and actually continue on with the rest of the job, or this is the part technically for everything I have. The other way we could go about machining this is changing it up a bit. I call this kind of pocket a traditional, your traditional pocket. And so we're taking this part off in these 150 thousandths depths all the way down to the bottom. The problem is the only part of my tool that's going to wear out is the bottom 150 thousandths of that tool. So depending on the material, depending on the tooling, depending on a bunch of different factors, we could also look into high-speed machining this thing. And to do high-speed machining, all we would do is go to our pocket right here, double-click on it, and then go to the patterns page right here. This is where we would then go use the adaptive roughing feature. Now, when you use adaptive roughing, you're doing a very different style of pocketing than you normally would with a traditional pocket. So right here, we have our adaptive roughing. Instead of trying to take a 40% step over, I'm going to go and take maybe a 5% step over. I actually use a program called GWizard to calculate this stuff. And the way that this one works is I can go in and say, I want to use a 3/8 diameter tool. And we're saying we're cutting aluminum, but there's a bunch of different materials in here, so I can change what material I use. I'm cutting it at a full inch deep. My chip load is there. It's set. I have 3 flutes, and I could say that my cut width is at 5%. So if I say 0.0375, that should be 10% about. So I need about half of that. So 0.01875. And there's our 5% step over. Now, depending on the machine you have set in here, your RPM is going to get calculated based on that. I'm also using this button right here called Use High Speed Machining. And if I turn that off, I'll get more realistic feed rates. This is the high speed machining feed rate. So I would take these values and I would plug them in. So instead of going at 150 thousandths for everything at a 40% step over, which if we were to say, 0.15, and then I was to say that my step over was closer to 40%, so 0.2, is this going to be too much? So 0.15, let me see what that gives me. About 40% right there. So you'll see we're running this around 55 inches a minute. But if I change this to 1 inch and I go back to the 0.01875, we're going to be at 124 inches per minute. That's without even including the high-speed machining strategy where we could potentially go way faster. So I'm going to use this because if this thing's telling me that I'm going to break a tool when I'm doing this, then I can't go this heavy. But according to this, I can go 1 inch deep. I could go with a 5% step over. And if I look right here, this deflection calculator that it has does not have it's not turning red for me. If you're not using GWizard because you have your standardized ways of doing, your feeds and speeds, this is definitely something you can take a look at. It's an awesome program, and then I just take the numbers from that program and I plug them in right here. And that's going to be the feeds and speeds I calculate. Again, we're going to go with a adaptive rough. We're going to set our step over to 5%. The minimal curvature radius is the smallest radius that's allowed to be used while you're cutting your part. So especially in this back part, because we're getting into corners, it's kind of like, how much do we really tuck into that corner? We're going to go until we hit a 50 thousandths radius, and then we're going to stop. Next, again, the other things that change when you're using the high-speed machining. You now have an option right here and right here. The first one is your link clearance. Your link clearance is saying, I want to go and raise up. Whenever I do these retract moves and I go back to the beginning of the cut, I want to lift up 20 thousandths. You can leave that at 0, so you stay right there on the floor, and you'll just kind of work down the floor. The other one's your breakthrough amount. Now, this is really important if you're using this feature for slotting, which is one of the best uses for high-speed machining, because a normal slot, I have to just cut right down the middle or, offset to one side, but I got to cut down the middle of that slot, and the first pass at least is going to be buried. The full 100% of the tool is buried in the material. If we do a high-speed strategy, then we're going to do more of these kind of spirally arcs, these trichoidal tool paths, and it's going to slowly work out. Now, this option is just asking, how far past the edge do we go? Do we break through just barely, or do we break through a bit more? I usually leave it right in the middle, and I'll adjust that if I need more. The other change we're going to make on this one is our depth. We're going to do this as a single step, 1 inch deep. Next, the leads, we should be starting off the part, so I'm going to leave it on plunge. The sequencing's the same. The links, we just get direct when we're using high-speed machining. The next one we have is the advanced feeds. Now, this does allow us to do some fancy things. The first one we'll see is the standard feed rates. Whatever feed rate we output, that's what we're going to run at. We also have our adaptive volume-based or our radial chip thinning. Now, usually when I use these, the feed rate that I entered in, the one that I calculated from GWizard, is going to be the feed rate I want to use. That's the fastest I want to be running at. So for me, with any of these options, I'm usually going to set the max feed rate to 100%. Or I'm going to take, if I use GWizard and I said that, it said I could go 124 inches a minute, I might set my feed rate to 110. And then I can say it's allowed to add another, 10%. So I could give it 110% for my max feed rate. Where it can speed up, it will. But usually I'll leave that at 100%. And then for the minimum feed rate, I can get it to slow down. Now, this radial chip thinning is calculating everything based off of the size chip that's going to be removed from the part. So if I say it needs to slow down, to 50% of the cutting feed rate, it'll factor that in. And it can use any range between 50 and 100%. So it'll slow down and speed up based on the chip size that should be coming off. I'm not going to do anything fancy with this one. I'm going to leave it right there at 50% and 100%. Other than that, that's it. So when we're done with that, there is no more updates to that feature. We can just hit compute. And come on, you can do it. Right there, we have our high-speed strategy. So another way of actually copying and pasting, because I like to do comparisons a lot of times, is I can right-click on this Open Pocket 1, and I could say Copy with Geometry. I want it to create the exact same toolpath. So let me rename this one to Open Pocket 2, because that's going to do this other Open Pocket. But I'm going to right-click on Open Pocket 1 and then paste that feature. So it says, do you want to use the same top and depth values? Yeah, I do. I want everything to be the same. It has the geometry. It knows that it's an open pocket. If I was to compute this one right now, it would be the exact same toolpath as what we have up here. But what I want to do is go back into this pocket, and I'm going to use the same tool. Right here, I'm going to tell it that I want to do a offset pocket out at our 40% step over. and then I'm going to go back. I'm just resetting it back to what we had it at before. So just like that, and then I can hit compute. Now, if we look at this, we have two different tool paths. Now, I didn't change any of the feed rates, but let's say on this one, we're allowed to go 50 inches a minute. It was like 52 or something. So 50 inches a minute on that one. I'll hit compute. On the other one, though, I'm going to say we're allowed to go 110. So I can go right here and say 110. And then I don't even care about the plunge feed rate. I'm just going to hit compute again. This might take a second to recalculate. So we'll just let it sit. And sometimes I'll do this so that I can see the time difference between these. If the time difference is great enough, I get a good time on the regular one or the, whichever one comes out better. A lot of times I'm going to end up trying to use the adaptive because I'm using the whole side of the tool, not just the bottom, 150 thousandths of the tool. So what I like to do with this now is I go up and I say, let's generate our setup sheet, just right here. And then I'm just going to hit OK under the full setup sheet. Now this is going to load into your internet browser. So I'm going to take this and I'm going to move this over. And so if we scroll down, we'll see that our first pocket, the one that we're using, the adaptive roughing on, cutting the full 1 inch is going to be 5.9 or 5 minutes, 9 seconds. Finish pass is going to take 36 seconds. But the other one, the second one that we did, is going to take 7 minutes and 3 seconds. And that's running at 50 inches per minute. So we can actually look at these two and go, okay, so if I run the first one, I can save 2 minutes on every part that I have to make. But the potential is, you got to know your machine. Is your machine capable of running at 110 inches a minute? I mean, it's a 5% step over. So it's not much. All you're doing is taking a quick shave of that part over and over again. And so there we have our two different times. Now we could do the same thing to the middle one, the inside one. And that one I'm going to do the right way. So for this one, what I'm going to do is I'm going to copy this feature. I'm going to say copy with geometry, and then right click on machine setup 1 and paste it. So paste it. And then it's going to use the same values. So yes. So we have our original pocket. Now we're going to take this second pocket and we're going to go down to the parameters under the pocket, the patterns, and we're going to set this to adaptive with a 5% step over. Everything else is going to be the same. I want to go in, I'll set up my tool speed at 110. Can't type, there we go. And then if I want to, I could also do those advanced feeds. So I could say this, 10, or we'll do 50 and 100, and then compute that one. So before I do this, I want to rename these features real quick. This one, oh, come on. I thought it'd be quicker than that. Oh, I still have to go change the depth on this too. That's why it's going to take even longer because it has to calculate that adaptive at a bunch of different depths. So we are just going to go in here as soon as it finishes. Come on. I'm going to open up this feature, go to the parameters page and set that to a single depth, and then recompute just so it has just the one. And it should go faster since it's not relinking and figuring out 4 different passes. So there it is right there. So I'm going to shrink that up and blank it out. So our first one we have is doing the adaptive. So I'm going to rename this one to adaptive. All right. And then I know that pocket one that's not adaptive, I'm going to move that up so that it's above the other one that we're doing. So we're going to do the regular one, then the adaptive. Then this one here is, again, a regular one. And then this final one I'll rename to adaptive again. And then if you're not sure, like when you generate your setup sheet, if you're not sure which features are which, you could also go in and rename these features under, or these operations under the feature. So if I rename this, I can say, same thing. I'll just say adaptive. I'll do the same thing for this. Well, the pocket doesn't, or the finish pass doesn't really matter because that should be pretty much the same for most of these. Rename this one as adaptive. And the benefit of that now is when I generate my setup sheet and I hit OK, it's going to load that up. Give me 1 second. I just have to pull it to a different monitor and then bring it in. It's going to pull them up with the name adaptive. So our original, again, 7 minutes, 3 seconds. Our adaptive pocket is 5.9 or 5 minutes, 9 seconds. And then right down here, we have our other pocket. It's 1:26 with the regular pocket at 68. I didn't change the feeds on that, but it's not really doing that much. How is it only doing 94 inches? Oh, total depth is 3/4 of an inch. And then the adaptive on that one's taking 4 minutes and 43 seconds. And it's doing a lot more work. Let me go check this one and just set the feeds on this to 50. And then we're doing our 40%, and we're going the full depth. Yeah, that is. All right, so we'll compute that again, and I'm just going to regenerate my setup sheet just to see if that, that's going to slow it down a little bit, but it shouldn't change it drastically. We're only going 18 inches a minute slower. So yeah, just a 2 minute there, 2 minute for that pocket or 4 minutes for the other one. So by putting them all together, I can go in and look at them. One, I'm still not even really getting into the speeds and the quality of it. What's it going to look like when it's all done? That's a whole different story. I haven't really seen that because I haven't simulated all these yet. But just looking at pure numbers, it might be worth it to do the adaptive pocket on the first ledge that we have, doing it here, but then using the traditional pocket to do that one. So you can change which one is which. Because either one, they're going to start off the part and kind of work their way into that. So that's going to be nice. So I'm going to go ahead and run this. We're going to do the regular one, which we saw. Now I'm going to go ahead and turn that off using the post yes, no button there. And we're going to do our adaptive pocket on the outside and our adaptive on the inside. And we can see how much different it runs. So I'm just going to give this a save. You'll see me save fairly often, but one of the times that I always save is right before I launch the simulation. So I'm going to say save and then start simulation. And then we're just waiting for it to launch. And there it is. So now we're going to be using the adaptive toolpath. And so this one's going to start off the part, once again, just like the other one, go full depth and then 5% on the step over. So real small. And we could probably be more aggressive than that with our step over. And that would definitely speed up the time more. We really probably could be closer to 10%. And again, that's something that if you have a program or a way of figuring it out, like GWizard, I can go in here and just say that I want to go 0.0375. And so we could be running at 90 inches a minute, but we're still at the full 1 inch deep. And again, that's not even using the high speed machining strategy. It says we could potentially run at 207 inches a minute, and that's actually already set to 50%. The speed that it says it can run at, 342 inches a minute all out. Now the machine that I have currently is a pretty beefy machine. It's got a 40 horsepower motor on it, spindle on it, and it's got a 10,000 max on it. So it's going to say we're going to run that thing out. What the heck? It's going to say it's going to run it to the full 10,000 RPM. And then, 342 inches per minute. So we're still cutting back here. I didn't speed it up too fast. And it's just going to continue taking that material down. And one of the big things about this, one, we're not going to burn out the bottom 150 thousandths of our tool, which is nice. The other thing is there's no 90-degree turns in this entire program in any of the adaptives. So your 90-degree turns are taken off. Your sharp corners are kind of taken out. So everything's going to be kind of a rounder motion. And let me slow this down. I'm going to do this. I'm going to say reset, and I'm going to skip right here to this adaptive. So right to this one. So we can see this initial entry into here is why this is such an awesome toolpath to use for slotting. So we could say run, and I want it to go slow enough that it doesn't take too long, but there we go. So we're just going to go in and just start chipping away at that thing. Instead of just burying the tool and moving in and opening up a slot in the middle, we're going to do that by just chipping away at it, just slowly taking out. Again, we could change this to say 10% for this step over. So we're not using, we're not wasting as much time. Do I still have my setup sheet? Yeah, right here. If we were to go that route, then that pocket that we have down here that's at 4 minutes and 43 seconds, if I could do that at 10% step over, take that time and cut it in half. So we're talking a little over 2 minutes. So we got 2 minutes, a little over 2 minutes. Let's call it 2 minutes, 20 seconds and 2 minutes. Well, now I'm close enough that extra 20 seconds might not matter so much to me. This tool path is still going to burn out the bottom tip of my tool, but this one's going to take the full 3/4 of an inch. So is 20 seconds worth potentially saving a tool for a little bit longer? That's up to you. So we can shrink that back up. We're still not done with it. And then it'll open up these channels using the same kind of strategy, the same kind of slotting strategy to open them all up. So no real difference in what we could see in the simulation as far as quality goes. The finish passes are really what are going to bring it to size, and we were able to use a G41 on those, so if they're not right, we can compensate them again at the machine. If we like the way this looks when it's all done, though, again, I'm doing multiple versions of this so that I can, in my head, figure out what do I think is going to come out better. I'm not even going to delete those other tool paths until I know that this is the one I want or I want to use the other one. So I can post out the code with all the high-speed machining strategies, or I could go in and I can post the code for the other one. I could make my decision now that I have kind of all my scenarios covered. Close it down. And I can choose which ones I want to output. And then after I do fully figure out which ones I want to run, maybe I want to do the adaptive on the outside here, but then I want to do the other open pocket. So I'm going to do the adaptive and the open pocket. What was that? Update all geometries. That didn't do anything. So I can choose which ones I want to use. And then again, later on, I could figure out, okay, I'm never going to run the first one, and I have no reason to run the second one. So the final job that I output, the one that I'm actually going to run, is going to be the adaptive and then the regular pocket if that saves me time. Again, if I was to take this adaptive feature, and we're already running under what it says, but I can say I want to go at 10 inches a minute, but we'll lower down to, or 10 inches a minute. We're that 10% step over. Jesus, right there, 10% step over. But now I'll take off, we'll go 10 inches a minute or 100 inches a minute because GWizard was around 90 something in there. So I'll do that. I'll hit compute. That alone should cut the time out of that final toolpath drastically. So I could turn this off or turn that one back on and then generate my setup sheet, hit OK. Now that I'm using something a little bit more realistic, we can get a better time comparison. So our original pocket, again, 1 minute 56. Our new adaptive with a 10% step over, 2:31. So 2 minutes, 31 seconds. So we're talking 35 seconds different. But again, I'm potentially using my tool and using more of my tool the whole time. So there we have it. Right there. And then if you ever need to save these setup sheets, I use Mozilla Firefox as my browser, and they don't have a right-click print option. Most of the other browsers, Google Chrome and the rest of them, you can right-click and there's a print option. I have to use Control-P on my keyboard. But then the way I save these setup sheets is with the Save to PDF option right here. And it's become my favorite one. I used to use the Microsoft Print to PDF, but most systems I've been on lately have this new Save to PDF option, or I think it's been around for a few years now. I just never noticed it. And with this one, I can say save. And the main reason I like it more than the other one is the other one doesn't bring in any sort of name. So for this one, it always creates the name as the setup sheet for, and then the name of my file, my Open Pocket example. So I could save it, and that's a PDF I could pull up at any other point in time and use it again. So right there. Any questions? No Q&A. Just trying to find. There is some of you guys might be on one of the other platforms. I'm looking at the one that I have on Vimeo. So let me see. We're live there. There was a way to do this. Yeah, we'll have to find it. But if you guys do have any questions, or if you're watching and you have a question, let us know. I can't see some of you guys might be on YouTube or Facebook right now, so I can't see those. I don't know why. So let me open them up on here. But if you do have any questions, we'll get you the answers. Just remember, pretty much what we've gone through today is if you have a solid model, you do not have to extract edges to do your open pocketing anymore. You just use the solid model. Just make sure that when you're picking the geometry for the feature, you choose the detect open edges option right there. If you leave this one off, you're picking the floor there, it's going to treat it as a regular pocket, like a closed pocket. So if you did do that, you'd have material left on, thin material left on the walls and a little material left on the corners, because the tool's not going to go in there as deep as it can. It's going to go in till the edge of the tool hits the edge of the pocket. So you'd leave little stand-ups all over the place. You wouldn't clear through this material here. You can still use the wireframe. You just have to make sure if you use just wireframe or you're doing 2D, the same rule applies. You have to use you have to use one of the advanced pocketing routines. You can't use the standard ones, which at this point, I really don't even use the standard patterns. Like if I open up this pocket here, go to the patterns, I don't really use standard pockets for anything anymore because it can only ever do closed shapes. But with an advanced pocket, I could do closed shapes, and I do closed shapes by not telling it that it's an open pocket. So I wouldn't click that button that says detect open edges. Or my geometry, if I'm using wireframe, my geometry is just wireframe, and it's going to be solid lines, and the system's going to read that as a closed pocket. So I can still use this advanced pocket for any situation. One of the biggest things people always ask is, how do you get better at it? What makes you the better? How do you do this? One of the things that for me has, I think, expanded the amount of time I spend programming is recognizing that I've done all of this stuff before. I've made pockets. I've done the high speed machining. I've done all of them before. Now, keeping track of that is a little harder. When I work with some of my guys that are doing training with me, I know we've done parts in the past that have the tool paths we want to use, but we didn't save them at that point in time. So now if we want to do copying and pasting, we have to go find a file that has those features on it. But a lot of times I've, working with so many of you guys, a lot of our parts are similar. We start with one part, and then the next job's a little bit different, but very similar. It's for the same customer. So it's a lot of the same stuff. Recognizing that I've used this pocket before on this specific material with this specific tool that I have set up makes it a lot faster in the future, because I can copy and paste or save and load those features. And then when you copy and paste or you save and load, all you have to do is pick the new geometry. And if it's the same depth and everything, you can just hit compute. You're done right there. If it is a different depth, well, just so happens that while I'm picking geometry, I can tell it the depth. The main benefit of copying and pasting toolpaths is the fact that, yes, the geometry is going to change. Yes, the depth might change. But all the rest of the settings that I entered into this, they're going to stay pretty similar. So instead of spending a lot of time going through and making sure all of our stuff's right, if I've copy and pasted a toolpath, especially a toolpath that I've run already, so I know I have good feeds and speeds, those are going to show up in here. So I have the feeds and speeds done. Next, again, you get to your patterns. You'd have your adaptive roughing. That's set. So is the step over. So is the minimal curvature radius. I don't have to change any of that. The only thing you'd ever really worry about would be, for me, making sure I have the right tool, which if I change tools, then my feeds and speeds might not be good. So I'd like to pick the pocket that has the right tool in it without having to change anything. But any of the little other things that we changed as we went through these features would also be changed when we copied and pasted it. So my profile finish down here would have parallel leads set to 1/4 of an inch. I might have to change that depending on what, where I'm using this. If I'm taking a pocket that I used for open pocketing and I want to use it on closed shape pocketing, well, I'm probably not going to use a parallel lead in. But going in and making just a couple changes is a lot better than trying to figure out all of the settings that you have to do. Just makes your life a lot faster. And for me, that's the big change in, the time. People always ask, how do you get better with it? One, use it. That's the biggest thing is just how often you get to use it. But I noticed that the guys that run, simpler machines like lasers and plasmas and water jets, they only have one toolpath that they run. They run a profile finish. They run this exact toolpath, except instead of defining an actual end mill here, they define the diameter of their laser, their plasma, or their water jet. So when they're doing this, after we have everything dialed in as far as what diameter does the plasma shoot at, what diameter are we blasting through with, after we get that dialed in, they never have to make another new toolpath. Now, that's not always the case. There's different scenarios. A lot of those lasers, plasmas, and water jets don't actually need any feed rate information from Bobcat. So what we generate for that is just the path for them to follow and the on-off commands for their torch or their water jet. So if they're lucky enough, there's some simpler machines that are like that, where the machine knows what it's cutting. The machine knows that on this job, I'm going to be cutting aluminum, but on the next job, I might cut steel. Well, in the machine, I would load in the feeds and speeds for the steel and then give it the same program as what I gave it from if I was cutting aluminum, because all we're doing is following the same path. So copy and pasting, saving and loading, and just making that connection and recognizing that, it happens to me when I've done a bunch of the same toolpaths over and over again. And I've made this toolpath before. Why should I make it a second time or a third time or however many other times? Why should I be making it all these extra times? And so recognizing that is a huge, huge time saver. And then finally, again, like I said, you'd figure out which one you want to use. You'd set your posting the way you want. You go down to your operations tab. You make sure that is the way you want. And really all we're looking at is these ones that don't have the post yes, no on them. So we're going to be doing the adaptive pocket there. We're going to do our finish pass. Then we're going to do our regular pocket there. And then we're going to do our finish pass. So those are the ones that I worked out and I liked, and they worked. One last thing about this operations tab that a lot of people have been missing is these two little icons down at the bottom here. You can actually take this bar and drag it up right where those 4 dots are, and it should stay like this from now on. But you have your operation tree, which is where we see the order that everything's going to go. We also have the tool tree, and this shows us what tool we're using. Just as an example, because I don't know if I can get away with this. Yeah, we probably could. I'm going to right click on my 3/8 end mill here, and I'm going to say I want to replace this tool for all these features. So I'm going to say replace, and it's going to ask me that. Do you want to replace this tool for all of these features? I'm going to say yes. And so now I can go in and pick a different end mill. So I can go in, I'm going to go ahead and pick my 1/2 inch flat end mill long. Hit OK. Now, when we do that, you'll see a bunch of exclamation points show up right here. That means that we need to recompute the toolpath to kind of update everything. So I can right click on that tool and say compute all toolpath. Now, when it finishes this, every toolpath that we created that was set up for that 3/8 tool is now going to be set up for a 1/2 inch tool. So I would want to go back into these features and make sure I set up any feeds and speeds, because the feeds and speeds are going to be set for the 3/8 tool. That doesn't change at all unless you're using system feeds and speeds. So make sure I got the right, feeds and speeds. The fact that I'm using a larger tool might allow me to take a heavier pass, so I could change my depth of cut for each pass. And I could change my step over. If I could be more aggressive with this 1/2 inch tool, then I could be more aggressive with a bigger tool. The difference is now, instead of having a smaller radius with the 3/8, I'm going to leave a larger radius in these corners. So I may have some more finishing I need to do or anything like that. But now we're going to be running it as the 1/2 inch tool. So same percentage on the step over for all these tool paths, but using that 1/2 inch tool. So we're technically taking out a little bit more tool path, or a little bit more of the part every single time. So there it is. Now that I have the tool paths that I'd like to use, that's the point when we go in, post the code. We're then going to right click inside this code and we could say save as, save it as the name of the file, whatever you need to name it, .nc, and save. And now we have the code that we could take out to the machine and run. We also could regenerate the setup sheet or use the same setup sheet as the one we made before. And there it is. Like I said, if anyone does have any questions, I'm not seeing a spot where I can get to the other streams that we have going. So I'll figure that out. This is my first time using this new system here. So I just have to find out how to do that, and I'll be better off next time. So if you are trying to get a question answered during this and you're on one of the other platforms, my apologies. You can just call us if it's urgent or you have anything you want to see. I don't know how to tell you to come over to this correct chat, but there it is. So open pocketing, creating tools. If you ever need to edit a tool, you can do it right on the fly. You can open up a feature and say, I want to change this 1/2 inch tool. I can click this drop down, go to modify tool. I can make my changes to the tool right there. And then the last one was really, I didn't spend too much time on it, but those spring passes. Your spring passes allow you to go in and recut the same area multiple times. If you ever have to do a bearing press fit or anything like that, add some spring passes to your final finish pass, and you're going to have a much better time cutting it. So there it is. Thanks, guys. Thanks for coming. We're going to end here. And like I said, if you do have any questions, I apologize if I didn't get to, I didn't see any in here, so I don't know. I'll go try and find out if anyone did recently. So there we go. And have a good one. I believe they're doing these every 2 weeks now, so we'll see you in a couple weeks. And if there's anything you guys specifically want to see, let us know. We love hearing what you guys want, and hopefully we can show it to you when we're doing these events. Thanks, guys. Have a good one.